Although there is no scrap metal in Pakistan, a gear that has been scrapped countless times, they only cut a piece of steel plate with a bird. It can be spliced together by Luo Wen's method. This kind of repair method is really rare. The gear in front of us that is broken from the axis cannot be repaired by ordinary welding. When the shaft head needs to be restored to concentricity, Fu directly chose a 3-stage splicing solution. Although this repair method is very complicated, it is a piece of cake for experienced level 8 front ends. After the gear and the claw plate are kept consistent and concentric, the next step is to process the entire fracture surface. Only the rough section needs to be cut flat. The original aperture needs to be continuously increased. The main purpose is to increase the force of the subsequent steel plate. Considering that there will be data errors if it is directly embedded, Fu will change the docking method of the entire gear. That is, the splicing surface is processed with fine threads. This can not only make it concentric and coaxial, but also make the two on the same horizontal plane. Then compare the gear with the thickened steel plate. The steel plate is the key to this repair. Such a thickness can fully meet the requirements of the gear. Then you can use the notch to cut out a circle. Obviously, the outer diameter of the cut steel plate is larger. This is because the error data of the handheld notch is large. Without the assistance of the isolation tool, it is necessary to reserve space for lathe processing. After simply expanding the original inner diameter of the steel plate, the outer extension of the steel plate must be consistent with the diameter of the gear end before splicing. After reserving the outer rock to cover the gap, it is also necessary to refer to the tooth tool on the inner wall of the gear to reproduce the steel plate with consistent threads to achieve seamless docking between the steel plate and the gear. This is the very rigorous processing of the master. The smooth docking of the gear and the steel plate can show that there is no error in the secondary thread. The spliced gear can obviously only be welded on the surface of the gap. In order to prevent the high-speed rotating gear from breaking, the master must drill holes at the edge of the steel plate to provide line positions for the steel plate with threaded docking. There will be loose wind racks after tightening the company's hole position with bolts. The remaining nuts will be removed by the angle grinder. At this time, the linear bolts of the steel plate are completely fixed. The shaft head will be cut into the steel plate. Before processing the inner diameter of the steel plate, Fu must first confirm the size of the outer diameter of the shaft head. After the embedded step is cut out on the fracture surface, Fu will process the same width of threads on the step surface, according to the existing thickness of the steel plate, to prevent the spliced shaft heads from having height differences. After the data of the shaft head is settled, the spliced steel plates can be finely adjusted according to the appearance of the embedded step. Because the two have not yet become a whole, the gap on the surface needs to be fully welded to prevent the steel plate from loosening and damaging the turning tool during processing. After the master has skillfully processed the thread, it can be docked with the external thread of the shaft head step until the two are completely fitted without gaps. After the master fixes it with a high-hardness welding rod, it is obvious that the protruding weld scar will also affect the use of the gear. Fu not only needs to restore the flatness of the background field, but also needs to cut and unload the appearance of the surface step. When the welding marks are completely gone, the scrapped gear can be used again. I like the exquisite craftsmanship of Master Ba Tai.